In this video, we're going to do some examples where we're asked to find the area under the normal distribution, but we end up needing to subtract to find the areas. And so there's a couple different scenarios where this happens. So the first one is if we're asked to find the area to the right of a positive z-score. So let's look at the picture. So remember, 0 is in the center. And if we have a positive z-score, it'd be over on the right-hand side. And if we want to find the area to the right of that, we would shade to the right, and so we'd have this picture. Well, the problem is that if we look up on the chart gives us an area between 0 and the z-score. So the chart could give us this area, but we don't know, we want to know what this area is. So we're essentially going to have to subtract, because we know that the area of the whole side, of the whole right side, is 0.5, is half, because it's 50% of the values. So what we'll have to do in this case is find the area on the chart and then subtract from 0.5. And then the other scenario would be if we want to find an area to the left of a negative z-score. So say you have 0 in the center and we put a line for a z-score that's negative, and if we want to find the area to the left of that, then what we would do is we would use the chart to find this area. And in order to find the area that we would want, we'd have to take the area of the entire left-hand side, and this whole area is 0.5. And so we could take 0.5 and subtract off what we don't want, which is the area that the chart gives us, to find out what we do want. And then the last scenario, which I created two pictures because it could be one of two things, would be if we want to find the area between two z-scores of the same sign. So let's say we have two positive z-scores. That would look like this. If we wanted to find the area between them, it would be this area. Now the chart could give us the area between 0 and the first z-score. It could give us that area. It can also give us this area from between 0 and that second z-score. And so what we're going to have to do is subtract the larger area minus that smaller area the chart gives us, and that will give us that shaded region. And then the last one would be if you want to find the area between two negative z-scores, which would look like this. And it's very similar to that last example where, you know, we're trying to find the area between. The chart gives us this area. The chart also gives us this entire area from between 0 and that z-score that's farther out, and so we could subtract those two areas to find the area that we need. And so now that we have a big picture of kind of what we're looking for, let's look at a specific problem. So here we're looking for an area to the right of z equals 1.95. So I'm going to draw in 1.95, which is almost a 2, and I'm going to shade that area to the right of it, and I'm going to figure out what the table, the z-score, the area chart can give me. The chart can give me the area from 0, between 0 and that z-score. So the chart can give me this area. I'm going to look and see what this area is first, and I'm going to write that down. So I'm going to look up 1.95 on the chart. So I'm going to have to scroll down, and 1.95 is all the way down here, an area of 0.474. So I'm going to go back to my picture. This section right here has an area of 0.474. I don't want that area though. I want this shaded region. So I know that the entire right side, so all of this, the area of the entire right side is 0.5 or 0.500, and I'm just going to add those zeros since there's three decimals with the areas on the chart. And so I can subtract the area that I don't want, which is 0.474, to get what I do want. So to find the area of the shaded region, I'm going to take 0.500 and I'm going to subtract 0.474. And if you're using a calculator, you didn't need to add those zeros there, but sometimes I like to do it if I like to subtract by hand, and we get 0.026 as a final area. And if we want that as a percent, we move that decimal 2 spots to the right, and we get a decimal of 2.6%. Okay, so for part B, we're asked to find the area to the left of negative 0.95. So negative 0.95 would be about there. And so we want to find the area to the left of that. So I'm going to shade left. And we're going to ask ourselves, well, what does the chart give us? The chart gives us this area right here. So the chart gives us all of this chunk. Okay, so I'm going to first look up on the chart what that area is by looking up a z-value of 0.95. So it looks like a z-value of 0.95 would be right here, an area of 0.329. So this area equals 0.329. But I know that the area of the entire right side is 0.5. So I can take that whole area of 0.5 and subtract the red section, the part that I don't want, to get the yellow section, which is the part that I do want. So I'm going to take 0.5 or 0.500 and subtract 0.329. Okay, and I get 0.171, or as a percentage, 17.1%. Okay, and then the next one, I'm looking for an area between 1.50, which would be about there, and 1.75. So really close together. So I'm going to shade those. So I'm looking for this area right there. Now the chart is I can look up a couple of things. So if I look up 1.5 on the chart, which is this line, this first line, 1.5, then the chart is going to give me the area between 0 and 1.5. So I'm going to first look that up. So I'm going to look up z equals 1.5, which is over here on the top right, and it's an area of 0.433. So 0.433. And then I'm going to look up 1.75. So if I look up 1.75, just going to scroll down a bit. 1.75 has an area of 0.460. So I'm going to come back and use a different color for that one. So this one right here, 0.460. And so if I take this entire region, so the 0.460 is between 0 and this outer line. If I take that entire area, which is 0.460, and I subtract 0.433, which is just this area right here from 0 to 1.5, then that will give me that small shaded yellow section that's between 1.5 and 1.75. So if I subtract these, I get 0.027 or 2.7%. Okay. And then lastly, it's very similar, it's just these are going to be negative. So if I have the area between z equals negative 0.60, that's a little bit more towards -1 than it is 0. So negative 0.60, and then negative 1.35, maybe about right there. And I want to find the area between. So notice in all of these pictures, the area that I'm trying to find is offset from the center. It doesn't touch that center line of 0. And so that's a really good way to just kind of figure out that you're going to need to subtract. And so I'm going to use the chart to look up this area right here. So between 0 and 0.60. So I'm going to use the chart to look up that area. And I'm going to look at 0.60. And remember that technically the z-value is negative 0.60, but it's okay because the chart or the normal distribution curve is symmetric. So 0.60 will give me the same area. So 0.226 is going to be that area. So this area right here is 0.226. Okay. And then I'm going to look up the area starting from 0 going to or between 0 and negative 1.35. So I'm going to look up 1.35 on my chart. And let's see, I'm going to have to scroll down just a bit. Actually, I'm going to have to go back up. That's the fun thing about using this chart. You sometimes have to do a little bit of scrolling. Okay, 1.35. So it looks like 1.35 is right there, and it gives me an area of 0.412. So I come back over here, and that area is 0.412. So the entire area between 0 and 1.35 is 412, but I don't want that entire area. I want to remove that white section because I don't need it. I only want the yellow. So I am going to take the entire area, which is 0.412, and I'm going to subtract what I don't want, 0.226. Okay, and if I subtract those two, then I get 0.186 or 18.6%.